For decades, humanity has relied on space telescopes such as Hubble, James Webb, and Chandra to reveal the universe with a clarity that Earth's atmosphere could never provide. Yet something remarkable has now happened. A telescope still firmly anchored to the ground has produced images so vast, detailed, and astonishingly deep that astronomers around the world paused in amazement. For the first time, the Vera Rubin Observatory has opened its eyes, and what it observed on its first night was not only beautiful but deeply surprising. It revealed a sky so crowded, dynamic, and alive with activity that it has the potential to transform the way we map the universe. Equipped with a camera the size of a small car, capable of capturing 3.2 billion pixels in a single image, the observatory can photograph an area wide enough to contain 40 full moons at once. The enormous volume of data it will produce could take generations to fully analyze. Yet even its very first images have already uncovered extraordinary discoveries, including merging galaxies, newborn stars, tens of thousands of ancient star clusters, and more asteroids in just 10 hours than humanity had previously discovered in weeks. This marks the beginning of a new era in astronomy, with a telescope powerful enough to watch the universe change in real time, capture cosmic events as they occur, and reveal structures no one even knew existed. Long before its first images were released, the Vera Rubin Observatory had already earned legendary status among astronomers. Located atop Cerro Passion in Chile, one of the driest, darkest, and clearest places on Earth, the observatory was designed not merely to take photographs but to survey the entire universe in a way no previous telescope had ever accomplished. At its heart lies the Simone Survey Telescope, an advanced three-mirror optical system that delivers both exceptional sharpness and an extraordinarily wide field of view. Its primary mirror measures 8.4 meters across, making it one of the largest of its kind. What truly distinguishes the observatory, however, is its integration with the largest digital camera ever built. Weighing nearly 3 tons and stretching 3 meters in length, the camera records ultraviolet, visible, and near-infrared light with extraordinary precision. Each image covers approximately 10 square degrees of the sky, an area equivalent to about 4 to 5 full moons. A single exposure captures what would require thousands of images from the Hubble Space Telescope to assemble. By scanning the entire visible sky every 3 days, the Rubin Observatory does far more than create still photographs. It produces a continuous time-lapse record of the universe, revealing flickers, explosions, collisions, and other cosmic changes as they happen. It is not a telescope designed to study one object at a time. It is designed to observe everything at once. When the Rubin Observatory captured its first images in June 2025, astronomers expected impressive results, but few were prepared for what they actually received. After just over 10 hours of test observations, the observatory produced a breathtaking 25 square degree mosaic that scientists quickly nicknamed the Cosmic Treasure Chest. The image focused on the southern Virgo cluster, the nearest large galaxy cluster to the Milky Way, and was created by combining 1,185 separate exposures. The completed mosaic contains millions of stars and galaxies. Elegant spiral galaxies stretch their arms across space. Merging galaxies twist together like clouds of cosmic smoke, and enormous filaments connect distant galaxy clusters into web-like structures. Hidden in the background lies a vast sea of faint reddish galaxies, each one potentially containing billions of planets. Astonishingly, this spectacular image represents only about 0.05% of everything the Rubin Observatory is expected to discover. Over the next decade, it is expected to detect approximately 20 billion galaxies, making this first mosaic only a preview of the extraordinary discoveries yet to come. As astronomers explored the image in greater detail, they saw not only breathtaking beauty but also direct evidence of cosmic evolution, with galaxies forming, interacting, expanding, and fading in unprecedented detail. The observatory has redefined what scientists can expect from a first image. If the first mosaic demonstrated the Rubin Observatory's incredible power, its next release proved something even more extraordinary, that a ground-based telescope could rival the depth and scale of the world's greatest space observatories. The Rubin team unveiled a spectacular wide-field image of the Lagoon Nebula, a vast star-forming region located approximately 5,200 light-years from Earth. Normally, telescopes such as Hubble present the Lagoon Nebula through highly magnified, close-up views. Rubin, however, offered an entirely different perspective. Its panoramic image showed the 55 light-year wide nebula occupying only a small portion of the frame, surrounded by countless stars and celestial objects spread across the sky. Within the same image appeared the open star cluster Messier 21, the glowing Trifid Nebula, Bochum 14, and the densely packed globular cluster NGC 6544. In a single photograph, the observatory captured objects separated by enormous distances and representing vastly different stages of cosmic history, from newborn stars still forming within the Lagoon Nebula to ancient globular clusters located thousands of light-years farther away. This remarkable achievement is made possible by the Rubin Observatory's extraordinary field of view. While the Hubble Space Telescope captures an area roughly equal to 1% of the Moon's apparent size in a single image, the Vera Rubin Observatory can image an area equivalent to 40 full moons at once, allowing astronomers to study the universe on a scale that was previously impossible.